What is greatness? It lies within us. Moving forward toward a better world, achieving the impossible, going further, taking it to the next level, to the next challenge, pushing boundaries, discovering, doing, thinking, designing, creating, and never, ever giving up the pursuit. That is our greatness, and this is our SF8. SF8 engineered for greatness.
Hola, muy buenas tardes a todos.
Hello, good afternoon, everyone, or good morning, or good evening, depending where you're watching us, because I know that you are following us from the United States, Latin America, the Middle East, and Spain. Thank you so much for being there. My name is Esther Vaquero. I am a journalist, and I am here today to guide you through the discovery of the new Soltec product, the one that you've already started discovering in this marvelous video that we just saw. For those of you who are just starting on this, and for those of you who don't, Soltec is the third manufacturer in the world and pioneer in Latin America. This is possible thanks to its 16 years of experience and a labor force of more than 1,300 people with a presence in Argentina, Australia, Brazil, Chile, China, Denmark, the United States, Spain, India, Italy, Mexico, and Peru. How about that? Soltec is fully dedicated to the research and creation of innovative products to offer the best technology in the solar industry. Today, we want to travel with you towards that future that for them is already part of the present. This is why I find myself in this spaceship on my way to that destination, which would seem unreachable, but that Soltec brings us closer to. Today, we'd like to introduce a new photovoltaic solar tracker that is going to revolutionize the market under the slogan Engineered for Greatness. Now, before we go into the subject, I'd like to remind you that you can ask your questions on the web page where you're following this meeting through streaming. And at the end of the day, we will answer some of these. Now I'm going to ask someone to help me pilot this ship. He is the CSO of Soltec, Eduardo de San Nicolas. He is an industrial engineer with more than 14 years of international experience in the solar industry. Welcome, Eduardo. Are you doing a routine inspection on the ship? Yes. Thank you so much for your introduction. Thank you for coming. I leave you in very good hands with Eduardo. Thank you, Esther. Thank you so much to all of you who are following this meeting from Earth. I feel very pleased to be here introducing this new tracker. I think I speak on behalf of all the people who form Soltec. We feel very proud of it. And I'd like to thank them for their effort and dedication, to all the people who have made this possible. And I'd also like to thank those of you who trust Soltec, because innovation is a journey we travel together. Like you, we learn every day, and that makes us better because our goal is always excellence. Those of you who know us know how much importance we give to a slick and elegant design, and of course, security. The SF8 has been designed following this roadmap: robustness, elegance, but always including the latest control and communication technology at the same time that we maximize production. The SF8 is an elegant, simple tracker, but also exceptionally intelligent and able to communicate in a way never seen before in our industry. It is tremendously robust. It is the largest tracker that we could imagine. It is a tracker of the present and the future. The SF8 has been designed to comply with all the requirements of the industry. It is a small step for Soltec, but it is a great step for the photovoltaic industry. And during this journey, you will discover with some of the people who have participated in its development the main characteristics and advantages of this tracker, and you will understand why we feel so satisfied with this new product. And I hope that at the end of this journey, you will all agree with us. Thank you all for coming with us on this journey, and I leave you with a video.
Planeta que tiene unas características pues de viento muy fuertes, unas condiciones atmosféricas y de terreno muy complejas, y queríamos demostrar que nuestro seguidor era capaz de instalarse y de funcionar perfectamente en las condiciones más adversas.
Pero cuando empezamos a crear el SF8 hace ya casi 2 años, ya empezar a pensar en él, desde el equipo de marketing siempre nos sorprendía cuando nos contaban nuevas cosas y nos dábamos cuenta del producto que teníamos entre manos y de lo que teníamos que presentar, lo cual nos alucinaba, nos flipaba.
Todo el desarrollo empezó con el nuevo diseño, la nueva geometría del torque tube, que es el tubo de rotación, el eje de rotación del seguidor. Queríamos cambiar la geometría para hacerla más fuerte y que aguantara más a torsión.
Con una forma patentada por nosotros, eso no existe en el mercado, que le confiere mucha más robustez al tracker.
Lo más grande es meter más paneles por una misma estructura y economizar, simplificar la instalación del seguidor, simplificar la operación y mantenimiento.
Es el tracker más grande que jamás hayamos imaginado, con un sistema de comunicaciones completamente novedoso que marcará un antes y un después en la tecnología fotovoltaica.
El tracker es capaz de despertarse, buscar la red que no es suya para conectarse y saber cuál es su red para comunicación.
O sea, es el tracker más robusto e inteligente del mercado.
Quiere decir más robusto, un seguidor que resista mejor los efectos del viento.
Nadie se ha preocupado tanto por afrontar el viento como nosotros.
Y de ahí pues, decidimos ir al tamaño del seguidor, hacerlo más grande. Partimos de un 2x45, vimos que podíamos hacer un multidrive 2x60 y también vimos que era bastante más ventajoso y más grande, tamaño 2x90, que es nuestro SF8.
Bueno, como se puede ver en el seguidor, no hay ningún elemento del conjunto motorreductor fuera, está completamente integrado.
Podemos decir que su belleza está en el interior.
Al ser un proyecto tan ambicioso, ha habido problemas, ha habido noches sin dormir, ha habido estrés, pero bueno, al final parece que todo ha ido bien y estamos aquí para demostrarlo y celebrarlo.
Porque una vez sale, una vez ya empieza a salir, te das cuenta de que todo ha tenido su porqué e incluso los errores aprenden de ellos y sale reforzado.
Pienso que es un seguidor elegante, es un seguidor original, podríamos decir, y bueno, estoy seguro de que todo el equipo está orgulloso al final del trabajo que hemos hecho, ¿no?
Ha sido muy gratificante encontrarte con un equipo que te ha arropado tanto, que ha trabajado tan codo con codo siendo gente tan diversa.
El objetivo de esta nueva geometría es tener un tubo con un comportamiento mecánico mejor que el cuadrado, pero no perder la facilidad que tiene el cuadrado de ser apilado, de ser transportado o de ser montado.
El 97% de los materiales que se van a usar en el SF8 van a ser materiales que van a tener un largo ciclo de vida.
Diseño que se puede montar de forma rápida, que se puede instalar de forma sencilla.
Que podría tener dificultades en la instalación, lo hemos desechado, porque siempre pensábamos en la seguridad del trabajador y sobre todo en la facilidad de montaje.
Hemos conseguido tener un producto muy competitivo.
Que pensamos va a revolucionar el mercado.
Te diría que es el tracker más innovador que ha sacado cualquier empresa de tracker en el mercado en los últimos años.
Estoy orgulloso de este nuevo seguidor SF8 y del equipo que ha trabajado en él.
Con el SF8 algo tan complejo como la ingeniería solar se convierte en algo simple.
Muchas gracias, Eduardo.
Thank you so much, Eduardo, for your introduction. I'm sure that our viewers want to know all about the SF8 and even more so, seeing how it was created. So without any further ado, why don't we take off for more? Okay, so here we are in Mars, the place where we're going to discover the SF8. Whilst we navigate through the planet, we're going to introduce the attributes of this new product. Its first differentiating feature is its robustness. I have with me the General Manager of Soltec Industrial, Sergio Lopez, industrial engineer with more than 20 years. Sergio, I understand that the SF8 is 22% more rigid than the previous generation of Soltec trackers. You know it in depth. How would you describe this new tracker? Well, the new SF8 tracker is full of innovations that we have developed based on our experience of more than 7 gigawatts delivered. The principles that have guided us in this innovation phase have been to provide a more robust tracker that will respond respond better to the effects of the wind, apply the knowledge acquired in the past few years, and implement the requirements of our customers in terms of ease of assembly, increase in production, etc. There are changes that you can see at first sight in the tracker, but others go unnoticed, like our monitoring and defense algorithms, the control system of the plant, and many small parts that solve many problems, particularly when you need to supply more than 50,000 equipment units a year. And these things are what make our tracker the best in the market, although it might seem the same as those of the competition. Why is this tracker more robust? Well, to answer this question, I need to focus on the mechanical innovations, mainly the following. It's a multi-drive system. What do I mean by this? As you can see, our tracker has grown in size, reaching up to 90 meters, which allows us to place up to 180 panels or 6 strings. In other words, we place double the number. This improves the use of the terrain available in solar plants. Having a multi-drive transmission system, the dynamic behavior of our tracker is much better, and the response to high winds is significantly better, avoiding problems with buffeting and flattening. So we have a tracker that will adapt much better to the wind speeds. We've also designed a new slewing drive. Usually we use the Corona worm gear, but we've decided to opt for a new drive technology, and we are the first to invest in this type of. It is more efficient, double than the traditional one, and therefore the motors consume less, and this improves the autonomy of the system. It's usually used for high precision applications, and the motor and the transmission can be in a concentric manner vis-a-vis the motor, and allows undesirable shadows or expose the rotation axis. They are able to resist greater strength. So either the tracker performs better with stronger winds, or you can optimize it if you want, is to get the same resistance than in the ones we use at present, and therefore we'll have a more competitive tracker. Another new thing is the torque tube. Before, we used square tubes because they have more advantages at a constructive and logistic level, but a square tube is not the best section to resist torsional stresses. The best thing is to use a round one. Trying to bring together these two characteristics, we have designed a new torque tube for the SF8. It's practically a round tube where we have flattened two faces. On the one hand, we considerably improve torsional strength, and together with what we said earlier about the multi-drive system, we improve the response to buffeting and flattering. On the other hand, since it has flat faces, we improve the joining other features. So with a tube with the same weight as the previous one, we improve the resistance to torsion by 20%. There's also a new connection to the module. Based on our experience, this joining area is critical. It's even more critical for the new 70-cell units. In this way, we unburden the support of the module, and this way we can use profiles that are optimized. Lastly, we've developed a set of small parts that give more rigidity to the tube.
I understand, Sergio, this robustness helps it withstand adverse weather conditions. Can you tell me how this new tracker works with strong winds. Well, for years now, we propose to apply to the trackers all the existing knowledge from the engine, from the wind energy, with the idea to make the trackers be safer. For this reason, we were pioneers in using wind tunnels for the sizing of the job. Also, then we carried out dynamic studies as well as buffering and flattering. These studies were reflecting in the first version of our Diawin, which is our calculation method that takes into account all these dynamic and aeroelastic effects. And we developed together with a Canadian company, RWDI, which is a world reference in the sector of the wind engineering. Currently, we've updated our Diawin with other wind tunnel tests. In this particular case, an aeroelastic test, which allows us to determine with more precision all the stress that the trackers have to support. We're also using CFD studies, both in 2D as 3D, which allows us to be more agile when we're studying the wind effect, studying new strategies, sizing new elements, etc. And then we can adapt better and quicker to the requirements and changes in the market, as for example, as I've already said, apart from improving the sizing of all the different components, we've implemented other advances, such as a new strategy against wind in 3 phases. The first one is a new strategy for defense,
Nos aseguramos de que el seguidor es estable para cualquier
to say that the tracker is stable against any wind speed. A new way of measuring the wind to be more assured that we have the right wind speeds, and also the wind gauges that have been used at the moment were changed, as well as the position of the plant. We have new algorithms to put the plant in stow and also to return it into operation to ensure that the tracker will never be in a dangerous position when we have a high wind event. All this knowledge have been implemented in the trackers that we have been developing up until now, but they are all part of this SF8. So in my opinion, this is one of the safe. As you said, Sergio, you developed the Diawin method together with a Canadian company, RWDI. Do you think we should connect to them so they can explain in more detail what the system's all about? Okay, in remotely connected, we have Matthew Brown, who's a principal and technical director at RWDI. This company is a world leader in wind imaging for skyscraper and is the main consultant in 7 of the 10 tallest buildings in the world.
Hello, Matthew. I'm glad to speak to you from Spain, and I hope everything is fine there in Canada. What can you tell us about the Diawin system?
Thank you, Esther, for the introduction. So what is this so-called Diawin method? Well, in short, it's a flexible hybrid approach that involves both wind tunnel testing and numerical analysis to address tracker stability, as well as predict all components of the wind load for design, which includes static forces, as well as inertial forces, which are predicted or approximated using dynamic amplification factors, which assumes small displacements, as well as aeroelastic or self-excited forces in the case of flexible structures, such as many single-axis trackers. Now, the static plus DAF or DAF loading is predicted using data from rigid pressure model research. The stability of the tracker is based on aeroelastic sectional model testing in combination with a numerical technique called flutter analysis, also known as FAM, to predict critical onset wind speeds of torsional instabilities such as flutter, as well as torsional galloping or divergence. And the output from a sectional model test is also used in another numerical approach called the buffeting response analysis method, also known as BAM, to predict dynamic wind loads that include aeroelastic effects. Now, in the Diawin approach, this BAM method, the buffeting analysis method, has been expanded to predict tracker responses for multi-row arrays. Now, the dynamic forces for ease of application are presented in a very convenient format as a function of damping and a non-dimensional parameter called reduced frequency, which is equal to the natural frequency multiplied by the chord length of the tracker divided by wind speed. And one of the primary benefits of Diawin is it offers a tremendous amount of flexibility to change many structural parameters without requiring additional wind tunnel testing. But for final design verification, we do recommend that full 3D aeroelastic model research be conducted, which Soltech has also undertaken. And this type of research involves taking a full-scale structure with its mass and stiffness and damping and shrinking it down to model scale so that you get both the applied wind force as well as the response of the tracker to that wind, including aeroelastic effects. So that is the hybrid approach, which has become known as Diawin. Now back to the set.
Thank you very much, Matthew, for being with us virtually. It's been a pleasure for all of us, and I'm sure that now our audience has an in-depth knowledge of the capabilities of this new tracker. Sergio, también me despido de ti. Gracias por contarnos cómo funciona este SF8 y por ampliarnos un poco más cómo es de robusto. Gracias.
Encantado, gracias.
We're going to continue to discover the capacity of the SF8, and now we're going to talk about its innovative system that converts it in the most intelligent tracker on the market. Now I have with me the CTO of Soltec Innovations, José Alfonso Teruel, and the PV coordinator from Soltec Innovations, Irene Muth. José Alfonso is an industrial automation and electronic engineer and has over 15 years' experience in the photovoltaic energy sector. And Irene is a doctor in renewable energies, and she's got 10 years' experience in this industry. So welcome. How are you? Thank you. Why can we consider the SF8 is the most intelligent? Well, the tracker controller and the gateway controller, which controllers are the brain of our device, with the communication center. They have high-performance processors and interfaces that allow them functionalities that up until now would be impossible. An example is the self-diagnosis, which is always running in the background and allows us to know the internal state of the processor and all the different parameters. In addition, the most important novelty is the wireless communication interface in mesh network. We can consider that we're the first manufacturer of trackers in the world that's adopted the open thread technology. Can you tell me a little bit more about these open thread communications? Of course. Open thread is a new mesh network protocol. It's developed partially by Google, and then it was freed, so it's an open protocol. And as main characteristic, it has a dynamic configuration and an auto-regeneration according to the conditions of the surrounding, which is a great advantage for our application, taking into account that their positions are changed throughout the day, and this means that this can block the communications network, and so it changes the network. So it's got low latency, which means that the communication speed is high and the response is high, which means that not just the data communication is in real time, but also the optimization of firmware OTA. And this is how you update mobile phones today. So these are much quicker and more efficient than they were in the past. This protocol, which is based on the 802.15.4 standard like Bluetooth, Wi-Fi and Zigbee, which are the standards that tend to be used in the industry, we've integrated the high-level protocol MQTT, which is a typical protocol that's trendy at the moment in the Internet of Things. And it's the one that we use on an applications level. So for these trackers and sensors of high performance, the MQTT protocol, which is easy to integrate in third-party systems, and it has to optimize the use of the surrounding because it's based on dynamic function, which is subscription publishing, which is like Twitter, and so the message only gets to the recipients who. Together, OpenThread and MQTT contribute a communication system that's robust and we're talking also about the fail-safe redundancy. What is this fail-safe redundancy? What it's all about? Well, with SF8 and full wideness, we've got to a level that when we started to design it, we never thought we would get that far with regard to system redundancy. We have achieved that no trackers need any special hardware or software which can be field signals repeater. So this means what we're doing with docking roles dynamically, and they repeat or not these signals according to the network's needs. No one is essential for the functioning of the other, so they're not critical. So we've achieved this with the gateway control units, but even better than that, because if a tracker stops communicating, you only lose that communication without affecting all the others. But if a gateway stops communicating, its effect could be much worse. For this, we have provided more radio communication interfaces so that they are able to adopt the trackers that no longer have the gateway gateway when they're in the neighboring field. This redundancy means that each tracker, or for each tracker, there is at least one main gateway and a reserve gateway that's assigned to them. All this redundancy feeds from shared information from all the gateways in distributed databases, which acts like a cluster, which opens up the door.
Bueno, yo estoy aprendiendo mucho hoy.
Well, I'm learning a lot with you. Now, Alfonso, you've just talked about a new concept, which is called distributed control. What is it? Well, we're full of surprises. Mainly, distributed control suppresses the control tasks that used to be housed in the plant central SCADA, like the wind information, snow information, time synchronization, team track, among other things, which are part of our advanced backtracking system. And there are other tasks that these tasks were executed at a central level because the control needed to gather all the information from the plant, apply algorithms, and execute the necessary commands taking into account the conditions. Now, thanks to the fact the information of all the plant is replicated in all different gateways that are part of the cluster, they are capable of knowing the information at a global level and then act locally, but with the note of all the actions that have been going on in the different gateways. So it's think globally and act locally. With this, we've eliminated the centralized control, which was considered a very critical point because in case of failure, it affected the entire plant. That is what tends to be called in English the single point of failure. This is everything we've wanted to avoid, and with everything I've said, we have improved all the robustness and the control system and also the availability of the redundancy of the system, and also improved the economy by reducing the cabling. But we've done more things that make the product cheaper. One of them is the new tracker control blocks casing. So what novelty does this new tracker control box provide? Well, it's the new casing that we're talking about, when inside you house the tracker controller and the second generation series SPAs, and also we have battery packs, which are LIF EPO, which double the life of the previous battery packs. And also we have optimized thermally the design. And one of the characteristics that's most outstanding is the way where they're installed in the field. They've got 4 mounting feet, which are pre-assembled in the box, and they position the box against the rotation axis, and then the box is closed and with using a lever effectance, which means that this box can be installed by one person. And then what they do is they put it next to the pile, and then they screw it in and they secure it. This means that the installation times have been considerably reduced to half. We've also reduced the cost of the assembly elements. On the other hand, this new casing has a new lid, which is independent for the battery pack, which means that you can replace any batteries without needing to access the system circuits, which are critical and you shouldn't have access to. So what are you saying about cybersecurity at an industrial level with these wireless communications? I'm sure it's very important, because we have gone from the architecture, taking into account the strict cybersecurity conditions. We divide into 4 main blocks, which the independence of the network and devices, and also encrypted communication, which whether they're wireless or by cable, redundancy and resilience. I've already talked about this. All the control and communication devices are self-powered with solar energy, and they have backup batteries, which gives them a lot of safety. And also, finally, the monitoring of the plant on a network level, controlling and detecting possible anomalies in databases. Well, I also wanted to talk to Irene. You have said that the SF8 can produce 8.6 more energy. So how does that happen? Yes, this 8.6% of gain in production is with respect to any other horizontal axis tracker in the market in a configuration 1 port. Basically, this can be divided into 6% for the team trap, which is our backtracking algorithm, 2.1%, which is produced by our tracker in 2-port configuration compared to a 1-port tracker. This data has been taken from BITEC, which is our Bifacial Research Center in Livermore, California. They take after 2 years of test analysis, and the last 0.5% is our new algorithm for bifacial, which is a bifacial team track. So how is this included in the SF8 and what does it consist of? On one hand, we have the team track, which I've already said, which is our tracking and backtracking algorithm. The tracking algorithm is based on the astronomy positioning algorithm, which is used for commercial positioning, and also our backtracking algorithm, which we've defined as asymmetrical. And this has been specially developed to optimize the positioning of the trackers in terrains with very irregular slopes. Each tracker has the possibility of being positioned at a different angle. They're independent, and in the calculation takes into account slope with respect to all the surrounding trackers. Therefore, they reduce to maximum the percentage of shade in the plant. So in this respect, we've got a lot of know-how, and the gain is being recognized by different external labs. On the other hand, we also have what we call our new algorithm, which is bifacial team track. This also includes what we've called the stow diffuser. What is this? Well, first of all, how does bifacial tracking work? Well, first it looks for a reflection balance between the rear and the front side of the module, by therefore optimizing the energy produced. To do this, and starting from the position facing the sun, it introduces several variations of the angle that maximize the radiation reflected to capture maximum reflection. On the other hand, we have the stow diffuser, which consists mainly of positioning the tracker horizontally on the days when the diffuse percentage is higher than the direct radiation. It's only activated on cloudy days when there's no sun. Therefore, they can maximize the radiation captured. So we've used field measurement systems. Irene, where can the stow diffuser develop its full potential? Well, the simulations that we've carried out show that it varies a lot according to the altitude. For example, in climates like Germany, it's activated about 6 to 8 days a year, which reducing towards the equatorial latitudes where maybe it's not activated or where that activation is a lot more limited. On cloudy days, we've measured improvements in production between 7 and 11%. This increase is distributed throughout the year. So the higher the number of cloudy days, the greater the impact in the global annual production. Well, to end, could you explain how the trackers in a 2P configuration like the SF7 or the SF8 produce more than the trackers which are in a 1P configuration when they use bifacial modules? Well, yes, it's this 2.1% of gain, which we talked about at the beginning. Over half of that percentage of improvement is from a more refrigeration of the tracker, due mainly to the height of the tracker, because it's a higher tracker. We're 2.35 meters off the ground at the rear side of the panel, and also due to an optimized design. Also, what has an influence in this percentage, it's got a less mismatch of the rear side, better making the most of the diffuse radiation, and also we're avoiding the direct shadow on the tube in the module. Well, thank you very much, Irene and Jose, for explaining so well this revolutionary aspect of the SF8. It's been a real pleasure to talk to you. And now, if you think it's huge now, let's go on to talk about the last.
I'm back to talk about the last characteristic that we want to talk about today about the SF8, and this time in a setting that is completely in sync with its essence, because apart from its intelligence and robustness, it has a minimum configuration of 2x16 and 4 to 6 strings, and it is adaptable to any terrain. I have with us Hector Sanchez, who is Vice President of EMEA. He's an industrial engineer with a 10-year experience. So why don't we watch, before talking to you, a brief video that will show our viewers why the SF8 is so elegant and simple. Hector, tell me, why is it that the SF8 introduces a significant change in how we conceive solar energy? Well, it does introduce a significant change, not only because of its innovations that we've heard about in this presentation, but also because we made sure we understood what the client is looking for and how to include that in the design of the tracker. I speak every day to our main clients in Europe, Africa, and the Middle East, and most of them coincide in that they're looking for three things, very important things for them. The first one is for the tracker to maximize energy production as much as possible, that it be reliable and competitive price-wise. And if we put all these needs together, that is how we have approached the design of the tracker. Maximizing power production is something that has always been part of this company. At the end of the day, we should not forget that what we're doing in the industry is to generate renewable energy and try to make it as cheap as possible. And for that, we need to look very carefully at what the trends are. Bifacial technology right now is very much present in the market, and we already identified that in the past. 2015, we developed the first large-scale bifacial project, and in 2017 we implemented or built a lab where we study what the components are that affect that bifacial technology. So with all that knowledge obtained during these past few years, we studied what things a tracker needs to produce more energy. With the SF8 design, we are avoiding shades in the rear side of the panel, and we understood what the best way was to move the tracker. And my colleague Irene mentioned that we can generate up to 8.7% more energy compared to a market standard tracker, focusing on how to move it, to get the most out of it, how to move it to make the most out of diffuse energy. And that, I think, is one of the strengths of the tracker. Now, we must combine that with reliability, which was my second point. So it doesn't matter if it generates a lot of energy if it's not reliable. And for that, we made it very robust. My colleague Sergio already mentioned a few things, but a great development is that the tube is much better structurally speaking. Its new geometry makes it more rigid. We're also using more drivers in the tracker so that the movement is more precise and more resistant. All of that combined with an improvement in the joints between the tube, the piles, which are that support the tracker. That joint has been improved. So this tracker is more energy efficient, but also more robust. And we shouldn't overlook either that it must be competitive. That has been one of the main factors that we set as a target, and less parts too. It has 5% less parts than the market standard. So that makes it cheaper not only in how much it costs to produce it, but also how much it costs to install it. And that also has a repercussion in lower maintenance and operation costs. So that's how we closed the circle. We made it more energy efficient, more robust, and more competitive. For me, therefore, it is a privilege to help to deliver this tracker in the market, which is the most technologically advanced tracker there is. And how does it affect the photovoltaic plant? Its configuration. Well, it does affect it a great deal. It's very large, but at the same time very compact, because 6 strings up to 180 panels in a short length. That means that it can be distributed very well in the plots of land. Usually the terrain is not regular. You only need to go around the countryside and see where solar plants are built, and it's very difficult to find a very flat piece of land. There's always hills. It's very irregular. So if the tracker is very compact, you can place more panels per hectare. And also that has an impact on generation, because if it's more compact, we can separate the rows more, and that will produce more energy. So it's a double effect. More energy production and more ease to install it. All of that taking into account that it minimizes excavations. It could withstand huge slopes of 17% north-south. That's a huge slope. The tracker doesn't need excavations or earth movement to do that. And that has another consequence, that is in helping biodiversity. Less excavations, therefore less impact of the civil works. And all of that combined with a tracker that is taller because of its 2 times configuration. It can also favor other activities for that piece of land, like cattle raising, because you can have sheep, cows, pasturing. Also agriculture. I come from a family of farmers, and for me it is a dream to generate electricity at the same time that I have crops. I think it's fabulous. I understand that all these advantages of the SF8 improvement in construction, better maintenance and operations, but how does it influence on all these things? Well, today we know that photovoltaic solar energy is the source of electricity that is cheaper in many countries, including Spain. And that means that the sector, from project developers to great electricity generation companies, manufacturers of components like we are, have a lot of pressure in terms of costs, and that also has a repercussion on the assembly. You have to assemble very precisely, but in very little time. And when you have a product like the tracker, it's much easier, because with less parts you can assemble faster. So we have less parts than the market standard, and in large plants 5% is a huge difference, where you can save a lot of money in the assembly and not only in the competitiveness of the product per se. Having 6 strings in the tracker means that the electricity installation is also easier and more concentrated. There are less piles too per tracker, and driving in the piles, the work there also is less than in other plants. So you save in the civil works, which also helps in terms of biodiversity. You take better advantage of the electric installation, and all of that has, of course, an impact on costs. and the cost of energy, which is what all investors are looking for, a lower cost.
Héctor, muchas gracias.
Un placer.
Sin duda estos beneficios van a interesar mucho a vuestros clientes.
Thank you so much, Hector. I'm sure that this is going to be of great interest to your clients, particularly EPCs. Thank you so much for being with us.
Ya estamos de vuelta en la nave y ha llegado
Well, we're back to our spaceship, and now it's time to answer some of our audience's questions. So I'm here with the CSO from Soltec. You already know, as I say, he's taken off his special space suit because he's finished all the work that he had to do on the spaceship. And I'm here with Mireia Jimenez, who's the product manager of Soltec. She is a mechanical engineer with 6 years' experience, and she has got a full knowledge of the SF8. So anyway, welcome to you both. Now let's go on to the questions. Okay, well, related to the structure, we have a question. What is the strategy for STOW? Who's going to answer that? Okay, I'll answer that one. Well, in the photovoltaic industry, they tend to think that there's a unique strategy and all the trackers should be in the one position or another, but that's not true. Everything depends on the design. With the SF8, as it's bigger, the majority of the plants probably means that the position of STOW, taking into account the strong winds, it will be around 40 or 50 degrees. But that doesn't mean that in certain projects, according to design, it could be at 0 degrees or at slightly tilted, and that could offer certain advantages to the design. For example, certain conditions or economical conditions are lower because of the foundations. Not one strategy is better than the other. It all depends on the design. And thanks to the Diawin, we have the knowledge to do this well. Other questions? What is the maximum length of the tracker? Well, there isn't a maximum length as such. All the time we've been talking about 90 meters because that's what we think is the optimum when we're talking about the Earth movement. But actually, our trackers are modular. It can be as long as you like, but the 90 or 100 meters isn't necessarily a limitation. We just say that so that you can optimize the length for Earth movements. But as long as you can absorb the tolerances, it could be longer. So does it mean that there are less? Well, in the video, you talk about less components. So what does this mean? Does it mean that the assembly times are quicker and the setup time is quicker? Well, it's a very good question, in fact, because previously my colleagues have been talking about which parts were being optimized or changed. There's one which is fundamental because the setup of the tracker, which is 2 vertical panels, and sometimes you have ones that are set up in vertical. And it all depends on the foundation. So there's a lot of savings on civil works. But apart from that, we've optimized other things. For example, my colleagues, when they were talking about the tube, is a lot more rigid and the shape's different. And so that means that you have to redesign other parts, for example, the joints for the modules and, as I say, the joints between the different profiles of the tubes, and all these different parts. We've talked about one important thing, which is the electronics, which is the brain of the tracker. José Alfonso, my colleague, talked about the open thread technology, which obviously entails lots of different things. And what this means is that you can integrate the Internet of Things. When we buy a lamp, for example, or a smart lamp, or a smart plug, sometimes with a mobile phone or just following a few steps, the network can detect these new components, and the setup time is reduced exponentially. And so therefore the trackers recognize each other and they're integrated in the mesh network, and you can minimize the time for commissioning, and it can be reduced to a third. Do you have anything to, if the other one would like to add something, well, feel free. Well, we're also asked here, does it interfere with other wireless systems? No. You have to take into account that our equipment have been through all the different electromagnetic compatibility tests, so they don't interfere with other equipment. Our communication systems are used from the EA802.15.4, and the other equipment, even though they use the same standard, like, well, we've talked about Zigbee, and the same as a mobile phone with Wi-Fi doesn't interfere with another mobile phone, and even though they use the same bandwidth, but they still work perfectly together. They have no problems. Is there a version for low temperatures? Is it valid to install in the deserts? Well, our main experience is in desert areas because the trackers have more solar performance there. And there also the terrain is cheaper, it's more accessible because you don't have as much environmental impact. But our tracker has a wide range of working temperatures, from temperatures that range, well, very low temperatures. We go to minus 20 degrees C. In fact, we have installed in very cold latitudes, or where the temperatures are very low. But sometimes, too, you can install them in the deserts, we've said, with very high temperatures in the Middle East. So apart from that, you have to take into account that the system has a battery which is self-powered. So it means the movement of the tracker. So this is powered by the solar panels themselves via a string or through another independent source. But the battery at the end of the day is what moves the tracker. So this battery is made of lithium. And all the batteries at specific temperatures, they don't charge up as well as they should do. So it's important to say that we've thought about these particular cases where the battery probably wasn't as recommended as it could have been. And so the system integrates, or should we say it can be, the batteries can be directly charged via cables. I don't know if, Mia, do you want to add something? No, just say that the communications are still wireless, but what would change? But they wouldn't be self-powered. They would have to be connected to the network. And also they will only work in temperatures lower than minus 20 degrees, but there's not many places like that. We've got more questions too. They've also got one that's related about the autonomy of the battery. Well, it's been designed depending where it is, but also in the range of temperatures, but normally it has an autonomy of 3 or 4 days in total darkness. So if it's very cloudy, and we've talked about the different algorithms about the diffuse options, well, it could even charge. So normally in total darkness, it will last for 3 or 4 days. So if you were to disconnect the battery from the load and it continues to be connected, well, it wasn't charging, but it would be connected to the tracker. So therefore, even if it wasn't charging, it would still be connected and work for 3 or 4 days when it's connected to the tracker. When the power connection in series, does this interfere in the string? Well, we're getting the energy from the string from our current, but we've estimated it's less than 0.02%, taking into account the consumption for the motors. They always consume the same amount, and the minor deviation from the maximum power point. But it's really not noticeable. And you have to take into account that 0.02% is even below the sensibility regime that an energy meter has. So you cannot really even perceive this. When the tracker moves, like when the engine turns on, as it's got a battery, and if you have a power peak, which happens when you turn the engine on, that's appreciated because the battery is like an energy buffer. And so then you get sufficient current so that it starts up without affecting the maximum power tracker point. More things. The metallic casing, can it have earth faults? Well, actually, the metallic casing is already connected to Earth. It's been designed that there is electricity between the casing and all the different facilities, and so it is immediately connected to the Earth. And this is what we talked about earlier, because obviously the electric current is the one that feeds the tracker, and so it's like 3 kilowatts between the entry. More questions. What are the cybersecurity measures against intrusions? Well, my colleague José Alfonso has already talked about this thing. And for us, it's essential because as we're talking about energy plants, the energy plants are a basic supply for society, and so they have to be well protected to all types of cyber attacks. Having said that, I would like to highlight that our connections are encrypted. They have individual codes for authentication, authorization for all the users who access that network, and for all the devices that connect to it, including the trackers themselves. At all times, we're monitoring the traffic in the network to detect any anomalies or intrusions or any type of incorrect functioning. We have a firewall between our network and other networks at the plant, so our network is always protected.
A ver, hay una pregunta un poquito más técnica, me vais a corregir si no.
There's a question that's more technical, so please correct me if it's not right. Why do you use the protocol MQ2TT with OpenThread and not with Zigbee? Mireia. Well, we thought about that at the very beginning. When we were researching, Zigbee was a bit better known, but then we realized that OpenThread offered advantages. José Alfonso has talked about it. And also, OpenThread has less latency and it self-heals, to say it in a specific way. And it's like mobile phones, so that the signal moves around the day, and so therefore the signal is shielded. So that what OpenThread does, it looks for the quickest route because it's got a dynamic network so that it does this quickly. And, for example, it sends alerts out to all the trackers at a specific time, almost instantaneously. So I think that's one of the advantages of OpenThread. Well, I think basically what Maria said is correct. So the difference is that when a tracker fails due to shielding or any other reason, so what it does, it looks for using the mesh network, the quickest route, and it picks up the strongest signal so that the entire plant is maximizing the communication and working properly. Well, thank you very much, Maria Eduardo. The time's run out. I'm sure we've got lots more questions, and if you haven't sent them in, feel free to send them to us because the Soltec team will answer any questions that are still pending. I would like to ask you, as I said, send these questions about the SF8 through the web. So now's the time to say goodbye. As you know, this is a tracker that's from a different world, robust, elegant, simple, intelligent, and prepared to revolutionize the market for solar panels. Thank you very much, Eduardo Mayor, for accompanying me now. And I would just like to say goodbye, and I hope that your relations with Soltec are long and lasting. Thank you very much for those who are connected from far away for being with us today and for allowing me to guide you through your journey. It's been a true pleasure. Thank you very much and see you soon.